Astronomers have sniffed the atmosphere of a distant super-Earth, and found a highly poisonous form of hydrogen. The exotic exoplanet, 55 Cancri, is over 8 times the mass of Earth and has previously been dubbed the Diamond Planet because models based on its mass and radius have led some astronomers to speculate that its interior is carbon-rich. Using new processing techniques on data from the NASA's/ESA Hubble Space Telescope, a UCL-led team of European researchers has been able to examine the atmosphere of 55 Cancri in unprecedented detail. The results will be published in the Astrophysical Journal. This is a very exciting result because it's the first time that we have been able to find the spectral fingerprints that show the gases present in the atmosphere of a super-Earth, said Angelos Tsiouras, a PhD student at UCL who developed the analysis technique along with colleagues Dr. Ingo Waldman and Marco Rocchetto in UCL Physics and Astronomy. Our analysis of 55 Cancri's atmosphere suggests that the planet has managed to cling onto a significant amount of hydrogen and helium from the nebula from which it formed. Super-Earths are thought to be the most common planetary type in our galaxy and are so called because they have a mass larger than Earth but are still much smaller than the gas giants in the solar system. 55 Cancri is a super-Earth, a rocky exoplanet about twice the size and 8 times the mass of Earth. It is one of 5 planets orbiting a Sun-like star in the Cancer constellation, and resides so close to its parent star that a year lasts just 18 hours. The planet is also tidally locked, meaning that it doesn't rotate like the Earth does. Instead there is a permanent day side and a night side. Since it is the nearest super-Earth whose atmosphere can be studied, 55 Cancri is among the best candidates for detailed observations of surface and atmospheric conditions on rocky exoplanets. The Wide Field Camera 3, WFC3, on Hubble has already been used to probe the atmosphere of 2 super-Earths, but no spectral features were found in these previous studies. 55 Cancri has a year that lasts 18 hours and temperatures on the surface are thought to reach around 2000 degrees Celsius. The planet is located in a solar system around 55 Cancri, a star in the Cancer constellation that is around 40 light-years from Earth. Because 55 Cancri is such a bright star, the team were able to use new analysis techniques to extract information about its planetary companion. Observations were made by scanning WFC3 very quickly across the star to create a number of spectra. By combining these observations and processing through computer analytic pipeline software, the researchers were able to retrieve the spectral fingerprints of 55 Cancri embedded in the starlight. This result gives a first insight into the atmosphere of a super-Earth. We now have clues as to what the planet is currently like, how it might have formed and evolved, and this has important implications for 55 Cancri and other super-Earths, said Professor Giovanna Tiniti, UCL Physics and Astronomy. Intriguingly, the data also hinted at a signature for hydrogen cyanide, a marker for carbon-rich atmospheres. Such an amount of hydrogen cyanide would indicate an atmosphere with a very high ratio of carbon to oxygen, said Dr. Olivia Vienot, Leuven, Belgium, who developed an atmospheric chemical model of 55 Cancri that supported the analysis of the observations. If the presence of hydrogen cyanide and other molecules is confirmed in a few years' time by the next generation of infrared telescopes, it would support the theory that this planet is indeed carbon-rich and a very exotic place, said Professor Jonathan Tennyson, UCL Physics and Astronomy. Although, hydrogen cyanide or prussic acid is highly poisonous, so it is perhaps not a planet I would like to live on. Since it is the nearest super-Earth whose atmosphere can be studied, 55 Cancri is among the best candidates for detailed observations of surface and atmospheric conditions on rocky exoplanets. Most of the early research on exoplanets has been on gas giants similar to Jupiter and Saturn, since their enormous size makes them easier to find. In recent years, astronomers have been able to map the conditions on many of these gas giants, but it is much more difficult to do so for super-Earths, exoplanets with masses between 1 and 10 times the mass of Earth. Earlier observations of 55 Cancri pointed to an abundance of carbon, suggesting that the planet was composed of diamond.